Hi, everybody, and thank you for joining us today for our webinar, Installation Systems as a Design Element. My name is Kim Melton, and I will be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. If you have any questions or concerns throughout the webinar, you can submit them at any point during the presentation via the Q&A feature, and we'll address these questions live at the end of the presentation. Now, if you don't see a Q&A feature to the right of your screen, look for the series of circular icons at the bottom in the middle of your screen. Select the icon with the ellipsis, and it'll open a menu that has an option for Q&A at the top. Select that option and then open the dialog box to submit questions, and that's going to open on the right side of your screen. Now, a quick note before we get started, this webinar is for educational purposes only and should not be used as a substitute for professional engineering design, consultation, or documentation that might be required by your building codes, contracts, or even applicable laws. If you have any questions after the webinar, you can refer to our specific application guidelines and instructions that are located on the product sections of our website. Additionally, we will follow today's webinar with a survey, and this is your opportunity to provide us with feedback on how we've done today. You can even use it to ask any additional questions you may have about the topic of the webinar or even suggest new topics for webinars you'd like to hear in the future. We're continuously striving to improve and evolve these webinars, so if you have any comments or suggestions as to how we can better accomplish this, or even if you feel like we've missed the mark today, we'd encourage you to fill out the survey, and we use your feedback to improve our webinars and provide the information that has the most value to you in future webinars. Now, this survey is also part of how we deliver the JM experience to you. The JM experience is based on 4 pillars of the JM culture, and that's people, passion, perform, and protect. And we believe it's critical to make sure that we hear and understand and respond to your needs in order to deliver the best interaction to you. And we offer webinars like this one to help educate the market and offer a tool and a resource for you in your business. But we understand that this isn't just a one-way street, so your feedback is a key component to helping us evolve to better meet your needs. Now, we're also frequently asked whether or not we send out these presentations upon their conclusion, and while we do not send out the presentation itself, we will post a recording of it online for you to watch at your leisure or share with colleagues if you think they might find it valuable. And this ensures that you can have the presentation within its full context, and when that's ready to go, we'll send out an email to you when it's live on the website. So with that, we're going to get started with some introductions. Joining me today are Sean Reynolds and Mike Cagle, and Mike is going to kick us off with some introductions.
Great. Thanks, Kim. Hello, I'm Mike Cagle, and I've been with JM for 32 years. I'm the business segment manager in our OEM group with responsibility for our office interior product lines.
Hi, I'm Sean Reynolds, and I'm the market development manager for the Northwest, covering our mechanical and HVAC installation products, and I've been with JM for 6 years. So, hi everyone, and thank you for joining us today. We're going to kick things off with a discussion about some of the latest trends we're seeing in the building industry. These trends range from energy efficiency protocols to the latest evolutions we're seeing in interior building design. So with that, let's take a look at what we're seeing in the building industry. Many of you are likely familiar with the current building trend known as net zero. Net zero standards help create buildings that produce as much or more energy as they consume. Obviously, this is one of the biggest movements towards energy efficiency. Taking buildings, which currently account for 40% of the energy consumption in the U.S., to structures that actually produce energy to the point of breaking even or being in the green in terms of energy production versus energy draw. In order for buildings to reach net zero status, they need several key components. First and foremost is insulation. This is key to ensuring that a building reduces its energy consumption. The second is energy efficiency. This comes in the form of windows and things like the electrical components in the building, like lights and appliances. The third component of a net zero building is renewable energy. Net zero buildings have to have a plan in place to be able to produce energy. We typically see this in the form of solar panels. In the net zero market, there are some key milestones that the industry has set as well. The industry is targeting net zero energy homes to be available in 2020 and commercial net zero energy buildings by 2025. These goals have required ingenuity and creativity for building designers as they have been challenged to find a way to make what has historically been a relatively costly endeavor into something that is attractively affordable. The second trend we are seeing that seems to align with net zero buildings is a substantial trend toward required increased energy efficiency in recent energy code updates. For instance, the 2017 Oregon Energy Code requires increased R values in walls, ceilings, and windows. In California, Title 24 requires that buildings built using 2019 standards will be 7% more efficient than those built with 2016 standards. This improved energy efficiency requirement comes through improved performance in attics, walls, and windows. In Florida, the 2017 Energy Code requires builders meet an Energy Rating Index, or ERI, target of 58 or better. And globally, the 2015 IECC, or International Energy Conservation Code, often the guideline for individual state energy code updates, calls for R12 insulation in climate zones 5 and above for commercial ducts in exterior or unconditioned spaces. Overall, codes are evolving to require more and more energy efficiency, and we expect this trend to continue. As a result, building design will have to continue to evolve to accommodate these new, more stringent energy efficiency requirements. Sustainability is another design principle that is trending, and while it's prominent in the building industry, it's a concept that is trending across a multitude of industries and business sectors. In terms of buildings, you are probably already aware of the numerous organizations that offer guidelines and methods of reporting to document a project's commitment to sustainability. Organizations such as LEED, the National Green Building Standard, Energy Star, and the Living Building Challenge call out product attributes moving the needle towards sustainability. Many of these programs consider the full life cycle of the products used within the building, exploring the full impact of the product from cradle to grave through documents called environmental product declarations. Additionally, some programs like the HUD Green Mortgage Insurance Premium Reduction Program offer financial incentives for adhering to their guidelines. Despite what we are seeing in trends towards energy efficiency and sustainability, we have also seen designs evolve to create spaces that can make achieving energy efficiency more challenging. For instance, a popular design trend we have seen explode onto the scene in the last 3 to 5 years has been exposed ceilings that reveal the building's HVAC systems. While some of these systems may not require insulation, as they are considered to be in conditioned space, there are many instances where insulation will be requested, and oftentimes, as we strive to meet these new energy efficiency codes, insulation may not only be requested, but required. Exposed ceilings create unique challenges. First and foremost is that it creates a larger space to be conditioned, which can be a drain on energy efficiency. If we look at the ducts themselves, they often need to be insulated for a variety of reasons. Temperature and condensation control, due to the variance between ambient air and the air moving through the ductwork. Acoustics, such as fan noise and crosstalk, and aesthetics and design. Oftentimes, the outward appearance of the insulation or facing does not appeal to the building designer. As a result, it has historically been challenging to find an insulation material that can be left with the facing exposed. Exposed ceilings don't only leave HVAC systems exposed, they can often leave piping exposed. Additionally, one of the common trends we're seeing in buildings is exposed piping in general. This is a motif that is very common in breweries or restaurants that have breweries. However, just like exposed ductwork, exposed piping also presents challenges. Process control, trying to prevent mechanical equipment from constant cycling to maintain temperatures. Temperature control. The material in the pipes, particularly in a brewery setting, can be crucial to producing the desired end product. Additionally, heat loss or gain on the pipes can become very costly if the system is operating at any temperature that is above or below room temperature. Occupant safety and personnel protection. Per OSHA standards, the General Duty Clause requires that you must protect your employees from receiving a burn as a result of touching a hot surface. A generally accepted temperature is 140 degrees Fahrenheit as a maximum temperature for exposed surfaces where an employee could be expected to come into contact with it. If there are exposed pipes in a restaurant, they could pose a burn risk to both employees and patrons. Condensation control. Condensation can damage other building materials, enable mold and bacteria growth, and present safety concerns. These concerns include trip and slip hazards, especially if drips fall into walkways or start to pool. Acoustics, the sound of the fluids moving through the pipes, and aesthetics and design. Typically, when people leave exposed pipes, they do this very intentionally because they like the industrial appeal of the space with the exposed pipes. However, again, it has historically been challenging to have exposed pipes that are also insulated. And finally, one of our favorite design trends and challenges, open office spaces. The benefits of open office spaces are many. They promote collaboration among coworkers. Open offices make management more approachable. They reduce construction costs with fewer walls. However, there are also drawbacks that are manifested in less tangible values than reduced cost. Open offices are often noisy and can reduce productivity. The open plans reduce security and privacy, and perhaps a bigger impact to some more than others, seniority can be overlooked. Now that we've discussed the more common trends we've seen in the building industry, I'm going to turn it over to Mike Cagle, who is going to discuss insulation considerations.
Thanks, Sean. So next we're going to review background information on what insulation is and some of the many benefits it can provide. There are many reasons people use insulation, but two that seem to rise to the top of the list are thermal control and acoustical control. Insulation materials can reduce the amount of heat and sound being transmitted from one area to another. There are several ways this can be done. Some insulation materials are formed to consist of millions of tiny pockets of air, as you can see in the magnified photo on the right, showing very fine fiberglass fibers formed into an insulation blanket. Air is a very good insulator, and trapped pockets of air are what give most types of insulation, from fiberglass to mineral wools to aerogels, their high thermal resistance. In addition to air pockets, void spaces, reflective surfaces, or materials with gas-filled pockets can retard heat flow. To help measure how well a material resists heat flow, the products generally are rated by an R value, or thermal conductance, K value. The higher the R value, or the lower the thermal conductance, the greater the insulating power of the material. Sean talked about code changes in various parts of the U.S., and it's important to realize that insulation products play a big part in meeting these energy efficiency requirements and improving overall building performance. As you can see here, there are many different types of insulation materials, from fibrous products to foams to aerogels. Some are better at thermal, sound, or fire control, while others may be better suited to lower or higher temperatures. In this presentation, our focus is mostly around fiberglass products, as they are widely used in the applications we'll be discussing. But I did want to touch on the other types of materials that are out there and the temperature ranges they can be used in. As you can see, insulations can cover a wide range of temperatures, and some insulations are better suited to extremely low temperatures, while others are better suited to very high temperatures. Many foam-type products perform well at extremely low temperatures, while calcium silicate, mineral wool, or ceramic fiber perform well at extremely high temperatures. Fiberglass is one of the products that seems to fall right in the middle. It performs best between 0 degrees Fahrenheit to approximately 1,000 degrees Fahrenheit. This makes it ideal for many commercial and residential applications that operate in moderately below or moderately above ambient temperatures. Historically, when people have specified insulation, they've been attempting to manage one or all of these components in their system: thermal control, acoustical control, condensation control, fire safety, and energy efficiency. We've already discussed how insulation helps reduce heat flow, and this is especially important, for example, to help keep your home or office interior at the desired temperature while reducing the amount of energy used to heat or cool. We'll be discussing how insulation can be used for acoustical control later in the presentation. Temperature differences between the system and the ambient air can often cause condensation issues, as Sean had mentioned. If the system isn't properly insulated with an appropriate vapor barrier, condensation can lead to mold or fungal growth. It can damage building components around the system, and it can also damage the insulation. As a result, controlling moisture can be a crucial component to protecting the integrity of the building. In the next section, Sean will be discussing various products that are helpful for moisture or condensation control. For fire safety, the flame resistance of materials is a primary consideration. Some materials are non-combustible, and some have fire-resistant chemical additives to provide flame resistance. In HVAC and mechanical systems, all materials are required to meet a fire hazard classification rating of 25 flame spread and 50 smoke developed to protect building occupants in the event of a fire. Finally, insulation saves energy, and in many cases, insulation uses recycled materials. This gives insulation products high marks for environmental friendliness. As we take into account the trends Sean spoke of, we have seen a new requirement for insulation manifest over the last several years. The outward appearance of insulation needs to be aesthetically pleasing to meet the desires of many building owners. Systems that should be insulated, like HVAC and pipe systems, are being left exposed, and the outward appearance or aesthetics of the insulation used on those systems has become increasingly more important in the design of commercial buildings. Since people care so much about what the insulation looks like on the outside, we get a lot of questions about whether it's safe or permissible to paint the insulation, specifically the insulation facing. Most people do not attempt to paint the fiberglass part of the insulation, and JM does not recommend painting the insulation facing under any circumstances. Insulation is required to meet a specific fire hazard classification rating when tested using ASTM E84 or UL 723 to protect building occupants in the event of a fire. This applies to all of the insulation used in the building, though the fire hazard classification requirements vary across applications, such as HVAC systems versus wall insulation, for example. These test standards outline the procedures for evaluating surface burning characteristics of products. Insulation materials are not tested with any sort of paint on the facing. As a result, painting fiberglass insulation facing could void the UL 723 rating, and as a result, painted insulation may not actually meet building code requirements. In a worst-case scenario, painted insulation may even present a potential fire or smoke hazard to building occupants. You might expect that the material should be fine if it's been painted with a UL 723 approved paint. While this seems like a fair assumption, most insulation manufacturers typically don't test their products with any type of paint or coatings because they have no way to determine which paint or coating would be the most applicable for every application. Since the material hasn't been tested with any paint or coating on it, even if the coating or paint you use to paint the material is UL 723 approved, the warranty will still be voided because the manufacturer has no way to guarantee the performance of the painted insulation. So the bottom line is that the insulation or insulation facing should not be painted. There are a lot of other solutions versus painting to make insulation products attractive. Now I'm going to turn it back over to Sean to talk about some of those materials and how they can be used to promote design aesthetics.
Thanks, Mike. So before we get started into the materials that are available for aesthetic applications, I wanted to discuss one of the common questions we face, and that is, do I need to insulate? This is a fair question. Historically, insulation has not been designed as a material that will be left exposed. As a result, the aesthetics have not been tremendously noteworthy. The unintended effect of this, however, is that many designers choose to forego insulation where it isn't required because it doesn't look attractive, and as a result, it doesn't suit their design. That being said, the simple answer to the question of whether or not you should insulate is yes. As you can see from the graphic on the screen, if you have a duct in an 80-degree space, the cool air in a non-insulated duct will rise 9 degrees over 100 feet. However, if that same duct is wrapped with 1.5-inch fiberglass insulation, the temperature will rise less than 2 degrees over the same 100 feet. If left uninsulated, this system will need to run longer and more frequently than one that is properly insulated. Thinking back to the trending energy efficiency requirements, it's fairly safe to assume that duct insulation is not a material that will be able to be left off for aesthetics for much longer. So that being said, what insulation materials out there are available that will allow you to insulate your ducts without detracting from the aesthetics of your application? We're going to start with the newer products on the market that are designed for applications just like exposed ceilings. In some cases, you'll choose to insulate exposed ductwork with an exterior blanket or duct wrap. Historically, this has only come with a foil scrim craft or FSK facing that is shiny and silver, because traditional applications have covered it with ceiling tiles or behind the walls. Now, however, you can get duct wrap in white PSK and as of this year, in black coated PSK. And PSK, as we see here, is a polypropylene scrim craft. With this type of duct wrap installed on the exterior of the exposed ductwork, system designers can use the insulation as a design aesthetic. Insulation on the exterior of the ductwork will help with temperature and moisture control and ultimately energy efficiency. When there is the potential for condensation, duct wrap serves a vital role in providing a vapor barrier. The black and white PSK duct wrap offer the same benefits as the FSK duct wrap. However, they are simply a more attractive product. These products, when installed with matching tapes, provide a consistent exterior facing appearance. Notably, the matching tape also has a matching scrim pattern, so there isn't a noticeable break in the appearance of the product between sections of wrap. The permeability of the facings, 0.02 perm, is consistent with other mechanical insulations. Keep in mind that duct wrap on the exterior of the ductwork does not provide any acoustical benefit. It should be used primarily for thermal control. Another advantage to PSK type wraps is that they can easily be wiped down for cleaning, if necessary. Be sure not to use an abrasive surface on the black coated PSK wrap, as it can be scuffed off if abraded. One common theme you'll see in a lot of exposed ceilings are spiral ducts. This industrial look is very popular right now in restaurants, commercial buildings, and even apartments. Designers like the silver of the industrial look, and if they have a specific color scheme they wish to adhere to, the ducts themselves can be painted with the appropriate code-approved coatings or paints. That said, spiral ductwork presents similar design challenges and is not immune to the issues we've already discussed. Application needs include energy efficiency, temperature control, acoustical control, such as fan noise, and condensation control. Now, if you don't want to insulate your spiral ducts in an aesthetically faced duct wrap, there are spiral duct liner products like Acoustic Plus that are available that insulate the interior of the duct. This is unique technology because spiral duct liner is a pre-kerfed fiberglass liner. The kerfs allow the material to be rolled into the circular shape of the duct for a perfect fit that sits snugly against the interior diameter of the duct. One of the benefits of spiral duct liner is that it can be installed into ductwork with an interior dimension of 10 inches in diameter or larger. Pre-kerfed duct liner contributes to both acoustical and thermal control, with NRC ratings and R value rising accordingly with the thickness of the insulation. The airstream surface of Acoustic Plus is coated with an antimicrobial coating. This helps protect the liner against microbial growth and helps to promote water repellency should any condensation happen to form. Lined spiral duct systems are lighter weight than their double wall or K27 equivalent systems. These systems require an interior duct that is wrapped in insulation to be placed inside the spiral duct, adding a substantial amount of metal to the overall system. For aesthetic purposes, one of the primary benefits of lined spiral duct is that designers get to keep the appearance of the exterior of the metal duct and, as I said previously, paint it should they choose to do so, while also providing the space with improved thermal efficiency in the ducts and less acoustical noise from the system itself. Just like spiral ducts, rectangular ductwork carries the same design objectives: energy efficiency, temperature control, acoustical control, and condensation control. Rectangular ducts can be wrapped just like spiral ducts can with the black or white microlight PSK duct wrap. They can also be lined with a rectangular duct liner like Line Acoustic RC. Just like the pre-curved Acoustic Plus duct liner, the rectangular duct liner has a coated airstream surface that helps protect the liner against microbial growth and promote water repellency. This type of liner also contributes to both acoustical and thermal control, with NRC ratings and R value rising accordingly with thickness. And just like the lined spiral duct, the exterior of the metal duct can be painted any color. Moving on from HVAC systems, let's take a look at the insulation materials that are available for exposed piping applications. As you can see, many of the requirements are the same as you'll find in the duct systems with a few more nuances. Occupant protection. Again, if you have hot pipes, you will want to make sure these are not left in exposed areas where people can touch them. It is a major burn risk that can be easily avoided. Energy efficiency, optimized process control, thermal control, acoustical control, abuse resistance, and moisture resistance. For fiberglass mechanical insulation, the industry standard is white-faced pipe insulation like Microlock HP and HP Ultra. In the mechanical industry, the thermal control of the insulation, or K value, is the inverse of resistance, or R value, which is what you find in the HVAC industry. K value is based on 1-inch thickness of any given material. R value is the calculation of K value over a certain thickness. For instance, a pipe with 2-inch thick fiberglass insulation at 70 degrees Fahrenheit mean with a K value of 0.23 would equate to an R value of 8.7. There are two typical paper-based facing options for fiberglass insulation that you'll find in the industry. Polytop, such as Microlock HP Ultra, has a 0.01 perm rating and is resistant to intermittent moisture, ideal for a restaurant setting and where wipe down may be necessary. Polytop, again, stands for polypropylene coated, and it is a crucial component that helps make the material more moisture resistant. All-purpose, or ASJ, all-service jacket, such as Microlock HP, has a 0.02 perm vapor barrier and is a very common choice. The primary difference between these two facings is the polypropylene coating. Visually, the Polytop coating creates a slight sheen to the product, while the ASJ jacket has more of a matte finish. Notably, all pipe insulations can be covered with aluminum or PVC jacketing for additional abuse resistance and aesthetic appeal. So let's talk about jacketing options for a few minutes. Unlike HVAC systems, pipe systems can often be more accessible, either located lower on the wall or, in the case of a brewery, sitting on the floor itself. This makes an insulation system much more prone to damage. As a result, it can often be necessary to protect the insulation with the jacketing. Additionally, if you don't want the white facing of the insulation to be readily visible, PVC comes in a myriad of colors that can offer both abuse resistance and aesthetic appeal. Zest-On PVC jacketing not only protects pipes and insulation from abuse by serving as a hard barrier between the insulation and the occupied space, but it also serves as a vapor barrier when sealed properly. This can be crucial for a system that is running at or below ambient temperatures. Zest-On PVC is an excellent choice for many aesthetic applications because it is available in a wide variety of colors. There are 14 different colors available, including UV-resistant white, in both 20 and 30 mil thicknesses. For applications like children's hospitals or schools, this variety of colors can be an excellent option to brighten up a space. One of the major benefits of PVC is that it can be wiped down or hosed down if properly sealed. This can be very common in food processing applications. However, keep in mind that the FDA does require the PVC to be 30 mil in thickness for these types of applications. It is also very common to color pipes for function in areas such as mechanical rooms. There is even one university that is installing colored PVC in one of their mechanical rooms to help educate their engineering students by making the pipes easily identifiable by color. Overall, PVC can enhance a pipe system's aesthetics and design while protecting the pipes and insulation from exterior abuse. Another exterior-facing option is metal fittings and jacketing. These are much more common in industrial applications. However, with the obvious trends towards exposed metal ducts and silver pipes, the application's design may call for a jacketing that is made of metal. Metal jacketing is typically made from aluminum or stainless steel and helps protect pipes against abuse. It comes in a variety of thicknesses and finishes, from smooth to corrugated to stucco embossed. Some metal jacketing can be washed or wiped down, but it is important to note that not all metal jacketing can be washed or wiped down. If you specify this type of material for an application that may need to be periodically washed, pay particular attention to ensure that the metal jacketing can allow for that kind of treatment. One of the major benefits of metal jacketing is that it can be used both indoors or outdoors and comes in different gauges for different applications. Whereas only white PVC can be exposed to UV light, metal jacketing is typically expected to be used outdoors. Silver, typically the default choice for metal, is typically a readily accepted industrial finish for aesthetics. And like most metal ductwork, metal fit can be painted as desired. Mechanical installations, such as large ductwork requiring board-type products, also present a design challenge, and unsurprisingly, the requirements remain constant: temperature control, acoustic control, moisture resistance, and condensation control. Products designed for large ductwork include white-faced fiberglass boards such as 800 series spin glass. This board comes in a variety of thicknesses and as a result can offer a very robust R value for the application. There are several types of facings available, including paper-based all-purpose facing and paper-based polytop facing options for added moisture resistance. Just last year, the market was also introduced to a paper-free polytop facing known as Ultra, made from aluminized polyester. Like the other polytop facings, this offers added moisture resistance. However, it doesn't introduce paper into the product makeup. The permeability of the facings remain constant at 0.02 perms. The board products have acoustical and thermal benefits as well, with 4-inch products reaching just over R17. So that covers the myriad of products that are available to insulate exposed HVAC systems and piping systems. Now I'm going to turn it back over to Mike, who will discuss materials for sound control and how to navigate controlling sound in open office spaces.
Thanks, Sean. So let's talk about sound control. As Sean mentioned earlier, open offices are becoming a very common theme in the commercial building industry, and that's understandable. They are more affordable and help create a sense of openness that can be appealing to many. However, they do come with challenges, one of them being sound control. In the next part of this presentation, we'll dive into the importance of sound control and how you can use insulation to tackle it. A common measurement presented for acoustical materials is the noise reduction coefficient, NRC. This is a measure of a material's effectiveness in absorbing sound in a space and is measured according to ASTM C423. It's an average across 250, 500, 1000, and 2000 hertz performance. The NRC is in place, like an R value, to help give us a unit of measure with which we can compare the acoustical performance of various materials. As you look at controlling noise levels in any given space, adding more absorptive materials reduces the reverberation time in a room and can also lower the overall noise level. When we look at the NRC ratings specifically, they typically range between 0 and 1, where 0 is for a product that does not absorb any sound, to 1 where the material absorbs all of the sound that reaches it. The higher the NRC rating for a material, the better it will be at absorbing sound across the typical speech frequency range. You may occasionally see an NRC rating that exceeds 1, but this is a result of how the material is tested. I should mention here that architects or designers may work with STC, or Sound Transmission Class ratings. STC ratings refer to how well a building partition prevents sound from traveling between rooms. It measures the reduction in noise between 2 rooms in decibels. One of the most important distinctions of an STC rating is that it measures the acoustical performance of the entire wall or floor system, the studs, the drywall, and the insulation as a whole, not just its individual components. In contrast, a noise reduction coefficient rating relates specifically to a single material's ability to absorb sound in a space. For practical use, NRC ratings can help building designers evaluate and compare materials to determine which materials are best suited to reducing or preventing sound transmission in their applications. To get an idea of the types of materials that can influence sound or sound control, we put together this chart to serve as an example. Keep in mind that this is an example for comparison only. Varying materials from different manufacturers may produce different NRC values, and before you specify any material, you will want to make sure you find its specific NRC value to ensure you will get the performance you desire. As we look at the chart, you'll see various building products and their typical NRC ratings. As you can see, the type of material has a major impact on the NRC rating and acoustical performance. Thin pile commercial carpets provide some sound absorption with an NRC of around 0.25. However, many facilities such as museums, hospitals, restaurants, or gymnasiums do not include carpet. They tend to utilize tile or even finished concrete. One thing we are seeing is that many open office plans spaces are moving away from carpeting as well. This further contributes to the overall noise level as hard surfaces like tile promote reverberation rather than inhibit it. When you look at the fibrous insulations like fiberglass and mineral wool, you'll generally find that they have high NRC ratings. For example, many fiberglass products have NRC ratings from 0.65 to 1. One thing to note is that the density and thickness of material also impacts the NRC. The insulation's properties like thickness and density play a substantial role in its ability to control sound. A higher density or thicker insulation can increase the sound absorption, especially across lower frequencies. The chart on the left shows how increasing the density of a fiberglass product can improve the sound absorption. The curves shown are for material at a certain density in pounds per cubic foot. As the density of the product increases in the curves from right to left, you can see that the NRC increases at certain frequencies. The chart on the right shows the same thing, but with a change in the thickness. Moving from a 1-inch product to a 2-inch or 3-inch product can increase the NRC significantly. Increasing the thickness of a fibrous insulation will generally have the greatest impact on sound absorption performance over increasing the density, though both material properties do impact performance. Keep in mind that sound control isn't just a nice-to-have feature in a building. Building standards that we generally associate with energy efficiency and sustainability, like LEED or the WELL building standard, also make note of acoustical control requirements for specific room types. You can see that for the WELL building standard, minimum NRC ratings of 0.9 and 0.8 are given for open office and conference spaces respectively. These values are for ceilings, and additional sound absorption products on the walls may be required to meet these requirements depending on the layout and size of the room. The T60 guidelines you see under LEED are another type of sound control measurement. The T60 measurement is a reverberation time, or the time required for the sound level to decrease 60 decibels. Equations can be used to convert between NRC and T60 measurements. So now that we've got a good idea of what sound control looks like, let's talk about sound control in office spaces. With the increase in open plan office environments, there's a lot of discussion on the impacts to productivity. Evidence regarding links between noise and workplace productivity suggests a trend to reduced employee satisfaction. Recent studies have shown that intermittent speech, something commonly encountered in an open office space, can negatively impact productivity more than continuous speech or a non-speech noise. While this isn't terribly surprising for anyone who has ever worked in this environment and knows firsthand how many distractions there can be, this is still a relatively substantial negative to open office spaces. Other sounds often encountered in open office spaces, like background music, have been found to be helpful in some cases, like sports performance, but can also be disruptive to reading. White noise, or sounds that mask other sounds, can also be used to combat these distractions. However, these systems can be difficult to implement and maintain successfully. The bottom line is that studies have shown that people are most productive when they are in a quiet environment, and even that silence is the best for accuracy and productivity. So, since we all know that silence is not an option in an office, much less an open office, what are some of the ways to control noise levels? In the next several slides, I'll be reviewing some of the advantages of utilizing stylized insulation to lower the overall noise level. This comes in the forms of acoustic wall panels, clouds and baffles, office partitions, and ceiling tiles are the tools we'll be discussing specifically. As you will see, in addition to improving the noise levels, these products can add to the aesthetic appeal of the space. Acoustic wall panels are an easy way to improve the acoustics in a room. The first photo shows an example of an insulation board wrapped in a fabric. In this example, the fabric is adhered to the insulation board. However, in some systems, fabric is actually stretched over the insulation material to give it a specific appearance. The insulation provides the sound control, and, as discussed previously, added insulation thickness can improve the performance of these systems. There are many different fabric options that provide attractive finishes. There are also options for unique printed designs and shapes, and these systems come in a wide range of colors. I've seen custom acoustic wall panels utilizing company colors or incorporating school logos to bring in a unique overall feel to the space. Acoustical wall panels are easy to install. In some cases, they come with hanging clips already attached. These products are very durable, and there are even products designed for high-impact areas. They are an inexpensive way to improve both the sound control and aesthetics of the space. Office partitions historically have been one of the most frequently used products to reduce noise in an office environment. They can provide some privacy and improve sound control for improved productivity. There are many different design options as well as a wide range of fabric colors. As with acoustic wall panels, the fabric may be bonded directly to the insulation or may be stretched over the insulation depending on the office partition design. These systems can also provide functional elements such as a tackable or writable surface, and they can complement desk and other office design features. Historically, office partitions or cubicles were used extensively in office spaces. With the shift to open office designs, the size of the office partitions has shrunk, and thus the amount of material to absorb sound has been severely reduced. With this, other acoustical control methods are needed. One of the most common products used for acoustical control are ceiling tiles. There's a wide selection of material available with varying NRC ratings. The most common system includes a grid system hung above the office space where the ceiling panels fit into the channels of the grid. Design trends are including more customized looks, such as the curved ceiling designs that you see on the picture on the lower right. And there are many different material options available for ceiling tiles in general in office spaces. If the office design doesn't include ceiling tiles, Baffles and Clouds are another excellent choice to control noise. These products have similar benefits to acoustical wall panels, but can be utilized throughout an office space. The unique designs, shapes, sizes, and colors available offer an infinite amount of creative choices. Many of the Cloud and Baffle designs include factory-installed attachment hangers, which make them easy to install with adjustable hanger wires. The spacing of the baffles should be considered if the optimal acoustical control is desired. This gets confusing with the different sizes and shapes of Baffle and Cloud designs. Technical product literature from manufacturers, or in some cases working with an acoustical consultant, can help with the recommended number of baffles or clouds and the appropriate spacing. As with acoustical wall panels, baffles and clouds are an inexpensive way to improve both the sound control and aesthetics of a space. In addition to the thermal performance benefits of fiberglass, these materials are excellent sound absorbers. They are among the most widely used acoustical material in a wide range of applications. Fiberglass products are lightweight, which makes them easy to handle on the job site, and they come in a wide range of density and thickness options. They can also be very economical versus other products such as foam materials. They provide excellent corrosion and mold resistance, as well as low fire and smoke properties. Finally, products utilizing fiberglass materials are easy to fabricate and handle for the installer. There are many economical sound control insulation options that can have a high aesthetic impact. As you can see in this photo, combining the various products we've discussed can give any space a unique look and feel. Many manufacturers even offer custom printed images for the finished surface of acoustical wall panels. And in addition to traditional office spaces, these products can be used for many different spaces, including movie theaters, recording studios, churches, museums, home theaters, or schools. As you look at designing interior spaces, don't feel like you are limited to one design because the insulation doesn't meet your needs. As you've seen in this deck today, there are a myriad of insulating options out there that can help meet the unique aesthetic design requirements of your application. Now I'm going to turn it back over to Kim to discuss some additional resources at JM.
Thanks, Mike. So if you're looking for more information about this topic or other educational resources, I'd like to talk to you a little bit about an online resource that we have called The Source. And this is where we house our training, our blog, specifications, and our recorded webinars like this one today. If you want to watch the webinars on demand or share them with colleagues, this is a great place where you can go and get that information. You can find our blog here where we have original articles, as well as these are articles written by JM, as well as articles written by industry experts throughout the industry. Our blog topics hit on targeted technical information, the latest news in the industry, and even scientific details that our research center has, I guess, revealed recently. But we do strive to make this content as rich and relevant as possible so that it can better serve you and the information that you need. There's also a full library of helpful documentation on The Source. So you see the specifications portal. It actually lists out all of our products and their NRC values, R values, EPDs. It's a very fast, easy way for you to get information specific to our product and product specifications that you're looking for. So if you go online, you'll actually be able to find this on our HVAC, mechanical, and industrial pages, and you'll find a link right there on the right side of the homepage. So additionally, we have a similar resource for our OEM business, and that is the OEM Engineer Portal. And this is similar to The Source. It's a little bit more targeted toward engineers, obviously, and it contains specification information for all of our OEM products, as well as sustainability information, tools, and recorded webinars that are applicable to the OEM business, like the one that you've joined us for today. Now, in addition to online resources, we also host what's called an Engineer Advisory Council, or EAC. And these are focus groups we host for engineers to discuss hot-button issues that they face in the industry and how we at Johns Manville can do a better job to help the engineering community address them. They're free to attend, and you can get a certificate of completion for participating. So if you're interested in attending the EAC, you can let us know in the follow-up survey, and we'll reach out to you when it's time for our next EAC. Speaking of certificates of completion, you will get one for attending today's webinar, and that should be in your inbox by the end of the day on Monday, October 14th. So with that, let's go ahead and take it to some questions. We've had a number of questions submitted early, and then we've had several submitted throughout the presentation, so please, just a reminder to submit them through the Q&A if you can. Now, our first question is for Mike. I'm going to send this one to you, and that is, do you have any suggestions as to how to control noise in an open manufacturing space around an etching machine?
Well, I'd say possibly a baffle type product or a cloud product. With the wire hangers, you can hang them from a ceiling that's quite high, so it's possible that you could hang those with hanging wires and clips to help with the sound control in that area.
Excellent, thank you. The next question is for you, Sean, and that is, you said the black PSK is black coated. Does it have any unique installation requirements because of this coating?
In regards to installation, no, other than you won't be able to set a piece of adhesive tape on it and pull it up to move it over. Otherwise, it would pull the coating with it. So that is one of the key reasons that the tape we offer to match is actually a nominal 4-inch width to help cover that seam or that joint aesthetically, and also eliminate the need to perhaps pull the tape up and reset it.
All right, great. The next one is for you, Mike, and that is, do they ever make acoustical panels out of mineral wool insulation?
Definitely. The acoustical panels can be made out of many different materials, all of which have different and unique properties. Some are better than others. We found that the fiberglass products from an acoustical control standpoint and an ease of handling have been widely accepted in the industry.
Excellent, thank you. Sean, the next one is for you, and that is, can colored PVC be used outside?
Unfortunately, it cannot. It is not a UV stable color that's in the PVC. The only color really that we would recommend on an exterior application would be the UV stable white.
Excellent, thank you. The next one is for you, Mike, and that is, in referring to clouds and baffles, are there any substantial differences in performance between the ones made from insulation board versus an insulation blanket?
I would say it depends on the thickness of the material. As I mentioned in the presentation, thickness is a large factor in the acoustical sound performance of the material. So a thicker blanket may perform as well or better than a similar board product if the thickness is much greater than the board product, for instance.
Okay, thank you. The next question is actually for me, and that is, can you get PDHs for archived webinars? Currently, that is not something we can offer, but it is something we are working on offering, and we hope to have that for you in the near future. So please stay tuned for that kind of for PDH option on our recorded webinars. The next one we have, Mike, I'm going to give this one, and that is, do you have any data on the effect of painting a glass fiber panel on the coefficient of absorption?
I personally don't. There may be literature out there that does. We'll have to get back to you with any further details that we can dig up on that.
Okay. This is the next question. So if either of you have any information, you can speak to this, and that is, my company has determined over the years that white noise in its manufacturing facility enhances productivity. Do you have any thoughts on this?
I'll take that, Sean. So I would say that white noise can be used effectively in many different situations. I think the key is that it needs to be tuned to the equipment that it's masking, and that needs to be, kept up to date. So there's some fine tuning needed with that, and you need somebody that's qualified in doing it. But it's definitely an effective tool to use in many different environments.
Sean, did you have anything you wanted to add?
No, I think Mike covered that well. I think it is a sort of application-specific concept in terms of the white noise being effective.
All right, excellent. Well, that wraps us up for our, we just had one more come through really quickly, and that is, why does HP Ultra pipe cover have a 0.1 perm rating versus the HP Ultra board is a 0.02 perm rating? Sean, do you know the answer to that?
Well, the facings themselves are actually different between those products. So even the exterior facing or outward facing aesthetic is the somewhat glossy white, but the Ultra board is actually paper free, and the jacket on the HP Ultra pipe does actually contain paper in it in that facing.
We've got one more for you, and that is for you, Sean, and that is the Spiroacoustic line duct. What thicknesses and densities does that come in?
So we don't really talk or speak to densities in liner products. It varies somewhat over the thickness, and that's really due to the facing as a component of the overall makeup of the product. But in terms of thicknesses, you can get 1 inch, 1.5 inch, and 2 inch Spiroacoustic Plus. Did that answer fully the question?
I believe so, but I can't speak for the audience. So with that, that is our final question for today. So if you do have any additional questions, or if we didn't get to your questions, there was one in here that relates a little more to building insulation that we're going to answer offline. But if you have any additional questions that you would like to have answered, you can submit those to us in the survey, and we will reach out to you directly. Otherwise, we thank you very much for your time today, and we hope you found this webinar informative. Keep an eye on your inbox for both the webinar recording email and your certificate of completion. And again, that's going to come to you by Monday, October 14th. If you have any questions, please don't hesitate to let us know, and have a great week.